Well, hello everybody. Hey, here's where I got to take you today. I need to cover with you section 7-1. What we do is we turn the corner on the second branch of calculus. The first branch of calculus deals with the derivative. Things that we've done with the derivative: slope of the tangent line, instantaneous rate of change, related rates, optimization that you just tested over. I hope that went very, very well for you, and curve sketching. What we do today is we turn the corner, and I just need to show you the notation and the formula for how to find the antiderivative, also called the integration, of a function. Where it's going to be used for as we get going, though, is area under a curve, and then volume as we revolve things about the x and or the y-axis. What you need to have in front of you, need to have that day one class examples in front of you. Guys, what I'm going to do on the first 9 problems here is we're just going to derive a function, and then we're going to write it with correct notation. And I hope you start forming an idea on how to find the antiderivative based on the notation. And then, of course, we'll come up with the rule just in case you didn't. So, if you would, look at your number 1. I'm going to give you f of x equal x squared. What I would like to do is find the derivative of this. So the derivative of this just happens to be 2x. Now here comes a true statement. That symbol right there is called the integration symbol, the integrand. It's also pronounced the antiderivative. So I'm going to say the antiderivative of 2x is x squared. Here's what this means. Whenever you see this symbol in front, it says, what can you take the derivative of to get 2x? Now, I'm also going to add in a little notation while I'm here. You'll always see a dx or dy or dt behind that. That just means we're finding the derivative with respect to the variable x. Later on, that's going to become a width of a rectangle for us. So here's a true statement. The antiderivative of 2x dx is x squared. Now to check this real fast, if we take this derivative, do we get 2x? And the answer is yes. Now, but let me do this to you. What if I take the antiderivative or the derivative of x squared plus 1? This would be 2x. The derivative of 1 would be 0. So the derivative of x squared plus 1 is also 2x. What if I did it x squared plus 10? Its derivative is still 2x. How about x squared plus 100? Well, its derivative is still 2x. Notice I could put any constant here and get a true statement. Well, to take care of that, we put plus c at the end of all of our answers. The c represents any constant. Now, I took 2 or 3 minutes on that first one, but let me kind of get going and you're going to start filling a groove for these. So here's my number 2. I'm going to find the derivative of 1/2 x cubed. Its derivative is 3/2 x squared. Here comes the true statement. The antiderivative of 3/2 x squared dx, notation, is 1/2 x cubed plus c. Now what's going to happen here in a little bit, guys, I won't give you this. I will only give you this part of it. You will have to get me to here. Now just to check it real fast, if we find this derivative, will we get back to that? And the answer is yes. But pretty soon, like I said, this part goes away, you'll be given this. But I want you to start look at the powers. Here's a 2, here's a 3. See if you can figure out a pattern between the powers and the coefficients. And then we're going to put them all together. Now I'm going to pick the pace up just a little bit. The derivative here on number 3, f prime of x, is going to be 2/5 x. Here comes my true statement. The antiderivative of 2/5 x dx, means I found the derivative of something, is 1/5 x squared plus c. C for some constant. And one last time to quick check. If I find this derivative, I should get that. But like I said, soon you won't be given this piece, you'll only be given this piece. So we need to figure out how to get from here to here. Here's my number 4. Whether we're in antiderivatives or derivatives, we still need to simplify if we can first. We still need to write them as rational expressions if we can also. So f of x is 2x to the 1/2. This derivative then becomes, bring that 1/2 down times the 2. So this derivative becomes x to the negative 1/2. Here's my true statement. The antiderivative of x to the negative 1/2 dx is 2x to the 1/2 plus c. For now, we're leaving the negative exponents because I want you to see a pattern from negative 1/2 to 1. Here comes my number 5. The derivative of this, bring that 3 down so it looks like I'm going to get 2x squared. Here's my true statement. The antiderivative of 2x squared dx is 2/3 x cubed plus the constant c. Here's my number 6. We're going to think of this as 3x to the 1/3. Let's go get this derivative. Bring down that 1/3 so it looks like I'm going to have x to the negative 2/3. Leave the negative exponent for now. Here comes my true statement. The antiderivative of x to the negative 2/3 dx is 3x to the 1/3 plus c. Now guys, while I'm here, this one's kind of an obvious one, the last two. Notice that when I gave you this, notice that the power is 1 more. Notice that the power is 1 more. We'll talk about how to get the number in front pretty quick. But doesn't it make sense? If we're finding the derivative of 5x cubed, we bring that down and decrease this by 1 and get 15x squared. Well, if we're trying to go backwards, we're going to have to add 1 to that exponent. So kind of start putting all that together. Here's our number 7. I'm going to think of this as negative 1/2 x to the negative 2nd before I do anything. Let's go find our derivative. So it looks like negative 2 times 1/2 is positive 1 x to the negative 3rd. Here's my true statement. The antiderivative of x to the negative 3rd dx is negative 1/2 x to the negative 2nd plus c. Let's put some more things together. To go from negative 3 to negative 2, notice that we added 1 to the reciprocal. So notice that if we add 1 to that negative 2, I'm at negative 1. And then we're going to multiply by the reciprocal. So that's where that negative 1/2 comes from. So we'll add, and then I'll multiply by 1 by that reciprocal. Here's my number 8. Let's think of this as x times x to the 1/2, which is x to the 3/2. So we simplified first. Now let's go find the derivative, which becomes 3/2 x to the 1/2. Here's my true statement. The antiderivative of 3/2 x to the 1/2 dx is, notice that that 1/2 is a 3/2, and then notice the power out front, so we're just going to have nothing there, plus a c. Now while I'm here, look at what happened. I added 1 to the 1/2 and got 3/2. And then I took 3/2 and I multiply by the reciprocal of the new exponent. You'll see that in a rule here in just a heartbeat. And then here goes our number 9. Once again, we will simplify first if we can. So x cubed over x is x squared. Negative 3x squared over x is negative 3x. 4x over x is 4. Now let's find our derivative. So I've got 2x minus 3. Here comes my true statement. The antiderivative of 2x minus 3 dx is x squared minus 3x plus 4. Now this one's a little different. I will show you how to get that 4 here later. That's going to be part of our rule here in a second. Now guys, as we went, I hope you put some things together. But since it's a video, I'm just going to tell you what you should have put together. Whenever we are finding the antiderivative of some function x to the n, to find that, we need to add 1 to the exponent, and then multiply by the reciprocal. Add 1 to the exponent, multiply by the reciprocal, and then put plus c behind it, unless it's a particular solution, and I will show you how to handle that here in a minute. Now, I should have you a little confused by now. So now, let's start cleaning everything up. Look at your number 1. Here's the question. What can we find the derivative of that would give me x cubed when I'm all done? So now we're going to apply our rule. What we are going to do is we're going to add 1 to the exponent, so it becomes a 4. And I'm going to put the reciprocal of the 4 out front. So the antiderivative of x cubed dx is 1/4 x to the 4th plus c. Easy to check. If I find this derivative, we better get that. Here comes my number 2. The antiderivative of 2x squared dx. We're going to add 1 to the power, so it's a 3. I'm going to multiply by the 1/3, and I still have that 2 out there. So my ending answer, 2/3 x cubed plus c. Now you'll like this. There's no fancy notation for this. There's my answer. Later on, here in a little bit, our notation will go from f prime of x to f of x. But the steps are the same. So guys, there's the answer. Add 1 to the exponent, multiply by the reciprocal. Now at any time you'd like, pause the video and try a couple before I go over them. But here's our number 3. The antiderivative of 1/5 x cubed. First, add 1 to the exponent, multiply by the reciprocal, and multiply by any constant that was already out there. So this answer, 1/20 x to the 4th plus c. All done. Now, just like our rules when we found our derivative, simplify first if you can. You may need to write it so that it's of the form x to the n. So why did I say that? On number 4, we're going to write this as x to the -3rd dx. That's going to be our first step. Now we're going to apply our rule. Add 1 to the exponent. Now notice -3 became -2 because we're adding 1. Multiply by the reciprocal. So my ending answer, -1/2x squared, we're getting rid of that negative exponent now, plus c. So there's that answer. Here's your number 5. Write this as something we can handle first. So let's think of this as x to the 1/2 dx. Let's apply our rule, so let's add 1 to the exponent. Don't touch your calculator. 1/2 plus 1 is the same thing as 1/2 plus 2/2. So it looks like this becomes 3/2. Multiply by the reciprocal, which is 2/3, plus c. And there's your answer, guys. Now number 6, I have a rule for you later on, you won't like it, that undoes the product rule. So we do not want to try to undo the product rule on this. So on number 6, simplify first. X cubed times x to the 1/2 dx. Go back to your Algebra 1 days. When you multiply, you add those exponents. So 3 would be 6/2 plus 1, so it looks like this is x to the 7/2 dx. Let's add 1 to the 7/2 and get 9/2. Multiply by the reciprocal, which is 2/9. Put a plus c there, and you got it. So there's my first 6. Number 7, we're going to simplify this first. So this becomes the antiderivative of x cubed over x is x squared. 2x squared over x is 2x. 3x over x is plus 3. We will find this antiderivative. Well, in this case, there's 3 pieces that we need to do. To find this antiderivative, we're going to find the antiderivative of x squared plus the antiderivative of 2x plus the antiderivative of 3. We usually won't split it up because it takes time. So the antiderivative of the x squared, add 1 to the exponent, multiply by the reciprocal. Let's move to the 2x. Add 1 to the exponent, multiply by the reciprocal, but notice there's a 2 out front also. Now, the antiderivative of 3, technically, guys, this is 3x to the 0. Add 1 to that, so I got x to the first, multiply by the reciprocal and get 3. So your final answer looks like this. 1/3 x cubed plus x squared plus 3x plus c. On to number 8. What we're going to do is simplify first. So x squared over x to the 3/2, subtract those exponents. So we've got x to the 1/2 minus 2x to the negative 1/2. Leave that as it is for a minute, dx. Now let's find each antiderivative. So add 1 to the 1/2 and get 3/2. Multiply by the reciprocal and get 2/3. Let's move to this next one. Add 1 to the reciprocal, or add 1 to the exponent and get 1/2. Multiply by the reciprocal, which is 2, times this other 2 that's still out there. Ending answer, 2/3 x to the 3/2 minus 4x to the 1/2 plus c. And then a couple more, then I'm going to show you what's meant by a particular solution. Here's my number 9. Oops, we switched variables, and we're going to have to simplify first. No big deal. Number 9, let's distribute first and get 3u cubed minus 5u squared plus u. I'm going to put that as a quantity, du. Now let's go get this antiderivative. Add 1, multiply the 3 by a 1/4 and get 3/4, minus, add 1 to the 2 and get a 3, multiply the 5 by 1/3 and get 5/3, plus, the u becomes a 2, multiply by the 1/2, plus c. And then there's your antiderivative. My number 10, we're going to FOIL this out first, aka we're simplifying this, so this becomes the antiderivative of 16t squared minus 4 times 5 times 2, so minus 40t plus 25 dt. Here goes my antiderivative. Add 1, so I got a 3. Multiply by the reciprocal, so there's 16/3, minus t squared. Multiply the 40 by the 1/2 and get 20. The antiderivative of 25 is 25t plus c. Now guys, don't let that 25 confuse you. Technically it's 25t to the 0, because anything to the 0 is 1. Add 1, multiplied by the reciprocal. Or another way to think about it, what's the derivative of 25x? It's 25. So that's how you get to your constant. Okay. So guys, I'm going to switch gears just a little bit, but I need to show you how to find a particular solution. That plus c just means there's an infinite number of solutions. Now, on my number 11 here, I'm going to show you how to get a particular solution. So it's going to be a baby step up from what we did. Here's going to be my first step. I'm going to find the antiderivative of 2x plus 2 dx. I'm going to find the antiderivative just like we did. Now the notation changes a little bit because I'm going to go from f prime of x to f of x. Now, this f of 1 equal 4 means that the ordered pair 1, 4 is on my new graph. So we got to go get that. So let's put it all together. Let's find the antiderivative of 2x plus 2. Well, add 1 to the 1 and get a 2. Multiply by the 1/2, so 2 times the 1/2 is 1. So far I'm at x squared. The antiderivative of 2 is 2x plus c. So here's where I am for a second. There's now some notation because we're going from f prime of x to f of x. So now here's what this means. I now have a parabola. I now have a parabola as my antiderivative. I want it to go through the ordered pair 1, 4. So now we're going to figure out what c would be for that to happen. So I'm going to plug in 4 in place of my f of x. So I've got 4 equal. I'm going to plug in a 1 wherever there's an x. And we're trying to figure out what c would be in this case, guys. So right now I'm at 4 equal, 1 plus 2 plus c, so it looks like c must be 1. Here's your final answer. My final answer is f of x equal x squared plus 2x, and my c is now 1. Now, notice that the notation changed, and then we figured out a value for c. I now have a parabola that goes through the point 1, 4. The x squared plus 2x was the antiderivative of that part. So when it says find a particular solution, it's like the derivative finding the slope of the tangent line at a certain point. Well, here comes another one for you. We need to figure out the antiderivative of 1 over 2 square root of x plus 2. So I'm going to think of this as 1/2 x to the negative 1/2 plus 2. I wrote it as something that we can find the antiderivative of. Well, here goes. Add 1 to the exponent and get 1/2. Multiply by the reciprocal, and I still have that 1/2 out there, plus 2x plus c. Now, let's simplify this. So here's where we are for a second. I now have f of x equal x to the 1/2 plus 2x plus c. That's where I am for a second. Now, to figure out our value of c, x is going to be 9, y is going to be 17. And we're going to use that information to figure out our value of c. So it's going to look like this. 17 equal 9 to the 1/2. 9 to the 1/2 is 3, plus 2 times 9 is 18, plus c. If we solve this thing for c, it looks like we're going to get negative 4. Now to get your final answer is going to be f of x equal x to the 1/2 plus 2x minus 4. I've got one more coming your way, and then I'm going to, of course, tie in a little profit, revenue, cost, because those things aren't going away. Here goes my number 13. Once again, guys, let's think of this as the antiderivative of 6x to the negative 2nd Technically, there's a little dx behind there. Let's add 1 to your exponents. So I got -1. Multiply by the reciprocal, and that's 6. So it looks like I've got -6x to the -1 plus c. So here's where I am for a second. F of x is -6 over x. I just got rid of that negative exponent, plus c. Now, let's go figure out the value of c by plugging in 5 and 2. So I got 5 equal -6 divided by 2, -3 plus c. Looks like c is going to be 8. Final answer, f of x equal -6 over x plus 8. If you want to check it, plug in that ordered pair there, find this derivative, and make sure you get back to the start. Now my last three, number 14, 15, and 16, are the exact same thing, but instead of using f of x, f prime of x, we're using c of x and c prime of x. So here goes. C prime of x represents your cost function. My cost function is changing at a rate of 8x minus 12, and the fixed cost is $10. That means that when I've sold 0 units, I'm out $10. Well, we need to find the antiderivative of 8x minus 12. So let's add 1 to the power there and get a 2. Multiply by the reciprocal and get a 4. The antiderivative of 12 is 12x. Then I've got plus c. Now do not confuse c of x and this c. This represents the cost. This represents some constant. So don't confuse those two c's. Now, let's figure out the value of the constant c. So when I've had 0, my cost is 10. So let's go 10 equal 0 minus 0 plus c. So c must be 10. My ending answer, 4x squared minus 12x plus 10. I got 2 more coming your way, but they're going to run the same. Here's my number 15. We need to find the antiderivative of x to the 1/2 plus 11. And then I need to use the ordered pair. 16 units cost $65. So here goes. Let's add 1 to the 1/2 and get 3/2. Multiply by the reciprocal, which is 2/3. Let's add in an 11x plus c. Now, where am I for a second? C of x equal. Now, let's plug in 65 for c of x. And let's plug in 16 for my x. And then if we solve this for c, I've already done that for us, guys. C is going to be negative 153 2/3. Or negative 153.67. So my final answer, c of x is 2/3 x to the 3/2 plus 11x minus 153 2/3. Now, my last one, nothing special, but remember when we were doing our derivatives, you're given the position function. After we found the derivative of the position function, we got the velocity. If we did another step, remember we got the acceleration function. Well, that's how we're going to hit this today. For a particular object, a of t is 3t squared plus 6, and at v sub 0, so the velocity at time 0 was 9. So I know the ordered pair I'm using is 0, 9. Find the velocity function. Well, here goes. I need to find the antiderivative of 3t squared plus 6. Add 1 to your power. Multiply by the reciprocal and that 3 out there, plus 6t plus c. So here's where I am for a second. My velocity function is t cubed plus 6t plus c. Let's use the ordered pair 0, 9. So 9 equal 0 plus 0 plus c, so c must be 9. The final answer, the velocity function is t cubed plus 6t plus 9. And guys, that's how you find a particular solution. Now, assignment-wise, I've got you on Math Excel, some problems there. That way, you can kind of check your work as you go. Math Excel definitely lets you know if you're right or wrong, but use our new little rule and you should be fine. If you have any problems, get in and I'll get you straightened out. Good luck.